is fiction. Science fiction. We make no guarantees, however, how long it will remain fiction. Fiction. Fiction.
Gigantic galactic greetings, everybody. This is Exofathom, the show where we like to talk about mythology and space and spooky things, among other things. And my name is Ayla. I'll be your host tonight, joined by my two lovely co-hosts in the squares over here, Nick and Mike. How are you guys doing?
Happy Friday. Doing well. How are you?
Happy Friday. Happy Friday. Doing okay. Doing okay. Mike, how about you?
I thought there was going to be some elaboration.
Mhm.
Gigantic? What was it? Galactic greetings?
Uh-huh.
You kind of fooled me. I was expecting like gigantic galactic salutations, and that sounded okay. But
I was thinking it.
I just got duped, I got juked or deeked. Like,
Hey,
Good
I'll
words.
make an exception for alliteration anytime.
Yeah, that's fair. Hanging in there. Doing all right. I'm trying to fight the environment at the current moment, but doing okay.
Nice. I hear that. Well, are y'all ready to talk about telescopies?
Mhm.
Telescopies?
Telescopies.
You're going to give us all the scoops on the scops?
Yes, I am. Good one.
Excited.
And you listeners out there, I hope you're excited too. We're going to be talking about telescopes. I don't know about you, but I've been excited about the James Webb Telescope ever since I first heard about it. It's starting to send back some images. It's putting itself together in space by itself, which is super cool. And it's an exciting time. You know, better instruments are going to yield better data and give us some more clues and answers about the universe that we live in. So buckle in. First half is going to just be about telescopes and space and humans. And then the last bit's going to talk about, you know, what makes the Webb telescope cool. But first, just to kind of think about space a little bit, do you guys have any memories like poignant telescope memories or your early memories of noticing the sky? And specifically like the stars in the sky.
That's a good question. I'm not sure. I think, I'm sure there was at some point where I first noticed the stars, but I couldn't tell you precisely when that was. I do remember going to the Balboa Observatory a lot as a kid, which I really liked, in Balboa Park in like the San Diego area.
Okay.
That was a lot of fun, and that had a whole bunch of space stuff, and there was a telescope there. So yeah, I mean, probably, you know, maybe 5 or 6 when I started going there pretty regularly. But yeah, a particular time when I noticed or contemplated the stars, I don't know. Yeah, maybe it had to have been older if I was truly contemplating the vastness of space.
Yeah, I could hear that.
You saying 4-year-olds can't contemplate?
I mean, maybe. I just don't recall if I was doing that.
That would be actually kind of interesting to see is like when somebody has their first serious thought about something.
Mhm.
Right. When you observe the child just stare up for a little too long and you're like, are you pondering over there? What you doing?
There was I had a student, he was pretty smart, and he was asking me all these questions on time. And we were on a field trip, so we were just sitting on a bus. And then I started to like give him sort of like some like elementary like time is like time doesn't exist type stuff. I wouldn't say that. I would just like bring up the abstractness, how it was an invention, and his brain started to break a little bit. I started to see like the more thoughtfulness come out, and I was like, so what do you think about that? And he's like, can you go sit over there? I need to be alone for a while.
Gave him an
Oh.
existential crisis.
Yeah, just give them a kid's existential crisis, but it teaches them to think.
Oh yeah, it does. But teaches them to think,
That's what's important,
Put some chop on that brain,
Like some wrinkles in that brain,
Thank
It's not
you.
so smooth brain anymore.
I was trying to think of like a good, like hair on the chest is to
yeah,
what
sort of
to a
thing.
brain. Wrinkles.
So I used to do this thing when I was real young. I still do it. Kitchen windows are really important to me, but I used to stare out of the kitchen window when I was a kid and look at the stars. Maybe about 5 or 6, somewhere around that age. I remember really starting to wonder about the stars and then just how, like, the mechanics behind the stars. So looking at it more as a astronomer than, say, like a poet that might find the twinkling, the aesthetic in the twinkling or something like that. That was the first stage, and then it really got cemented when I started playing a lot more like Civilization, a lot more video games, because optics and telescopes become really important, and it might be one of the most important inventions of the whole time. But yeah, no, the first thought of the stars had to be around like 5 or 6, just staring out of a kitchen window as a kid.
Yeah. Yeah, no, I hear that. I think it's interesting how you get introduced to the night sky, because usually, I mean, outside of what, 4th of July, maybe, how often are you outside in the darkness as a kid? Like you're usually like in bed by 7. But I remember as a kid being on the res, and at nighttime, if you had to go to the bathroom, you had to go to the outhouse, which was like a good walk away. And so it's high elevation out there, and you can see a lot of stars. There's like very minimal light pollution. So you can actually see like the Milky Way a little bit more prominently. And my dad used to always talk to me about the stars. I think that was my first introduction. And then as far as like really thinking about like space and stuff, and I've said this before, it was when I saw Saturn's rings through a telescope with my own eye. I've seen images. I always knew that was there. I wasn't going to doubt the copious amounts of evidence, but there was something about seeing it with my own eye that just made such a big difference. And curious if you guys, like, have you ever seen like a shooting star that gave you that kind of feeling, or like an
Are we
eclipse?
going to get on the very awkward grounds of Astro Camp?
Oh, Astro Camp. No, but it's a good camp. Space Camp, California, Idlewild. It's beautiful.
That was the first time I saw any of the rings around Saturn. And then I got in trouble because I touched the telescope. And it sticks. The memory of me getting in trouble sticks with me more than the memory of seeing Saturn.
That's a shame.
Well, it tells a lot to my psychology.
Right.
But that was the place where I got to see like the rings of Saturn, see Mars in all of its glory. Mars is my second favorite planet. But yeah, I have. Have you, Nick? Have you ever got to view the?
No, I've never looked through a telescope before.
Not even once. Not even binoculars.
Binoculars, yeah.
Well, if you cut the binoculars in half, don't you have a telescope?
I mean, yeah, but if we were talking about space telescopes, I haven't looked through them before.
I'm so dragging you to Griffith Park one of these days when I can drag somebody.
It's cool. From what I've seen through, photos of stuff or people like, videotaping it, it looks impressive. It's kind of eerie, almost like you're looking at something. I don't know. It's like almost like you're looking at a miniature, like from an old movie, because the space is kind of this like not too black, but it has like this kind of white matte black to it, and then you see this tiny little planet with some rings around it, and you can pick up just tiny bits of movements, from the storms or whatever. So that to me seems pretty trippy, like being able to take your eye look through something and then see something, thousands, hundreds of thousands of miles, millions of miles away. Yeah, that's crazy.
A bunch of curved lenses, right?
Yeah.
Curved pieces of glass.
Well, and I think you used the word eerie, and I think that's a really good word because something, if you look at a star, you've looked at stars your whole life. I mean, you're used to it. It's like there's millions of them, nothing special. But then you see Saturn, and there is an eeriness about it looking like a star, but it has a little star ring around it. And it's just it's unique, it's different, and it really makes you think like over the civilizations and over the history of astronomy, seeing those kinds of outliers are just so like I have to learn more. And I think that's such a human thing, that curiousness and that like drive for knowledge, especially when confronted with something that doesn't adhere to everything that you've been witnessing or seeing.
Yeah, I think it would have been crazy to be the first human to utilize a telescope to see Saturn or Jupiter or even Mars. I mean, Mars is closer. But yeah, I mean, what would you even like I'm sure telescope technology was very familiar, so people were acclimated to it, but it's like, what would you tell that person who's like you're trying to explain a telescope to? And the curved glass thing is very, technical and accurate, but it almost feels like it's like some sort of window into a portal or something. Like if you were more
hey, shut up and
religiously.
Yeah. Look at this.
Right.
I think
a lens through hell.
Right. Or like if you look through it, you get possessed by what is that and what's way over there, and it's like don't look through the possession scope. It's gonna take you, like take your innocence or something. I could see that. Yeah. I mean, it would be. I mean, anything's a little bit scary, if it's like unfamiliar.
All technology has a bit of.
No, does that drive astronautics? Like just seeing because there are like a few planets you can see with the naked eye, correct? But I don't know if during the times before optics they had to know they were planets, right? Because they shine differently or something. I don't know. I'm just trying to think like, what was the drive towards wanting to go there? Was it the telescope, like with the early telescopes where you look through and like, man, I can see it, but I just want to be there. What do I do just to get there?
Yeah, well, gosh, I think I was watching like some silly movie where there was a quote that was talking about like the question, like oh wow, it was such a silly movie. It was Owen Wilson and Jennifer Lopez in a romantic movie that came out this year. I forget what platform, but anyway, he's a math teacher and he says that like if you can't find the answer to something, like hone in on the question. And so I think that's kind of probably part of the driver is that like you use the telescope, you make these observations, you see what you see, you get data from that, but then you end up having more questions. And so to figure out those questions, you refine it and you're like, oh, well, maybe I can upgrade my observational tools to upgrade the types of questions I'm asking. And so, yeah, I mean, that would definitely lead us to eventually be like, well, if I can get closer to that, let's go for it,
Yeah, because even with our drones, we're on Mars. We're very close, but it's not anywhere in the same league. I was going to say same ballpark, but different league of if we were actually had people on Mars, right? It's still like it draws us closer. It's like some mathematical terms. It's like some weird asymptotic behavior. We want to get closer and closer and closer until we can build the tech to finally touch the thing.
Is there are there space cartographers? Because I would love a map of space.
There has to be.
I mean, like I really hope there are. I'm not being silly. I just thought about it now because we're talking about how optics
Ooh.
is sort of the first step into exploration. We mapped things out back when we were exploring the world. Like it would be amazing to see like what we conceive as a map of space right now, and then compare it to 100 years from now or 100 years ago. I would love to see
Oh,
that
I
if
don't.
that's out there.
I'm sure it's out there. I don't know if you want to dive down the photography rabbit hole though, because there's a bunch
Well,
of different maps of the Earth, of our own Earth, in different styles and different ways.
Oh,
to
I
look
know.
ooh,
Yeah.
that's an episode for sure. I
all
would
have
love
their
that.
strengths and weaknesses, or just weaknesses.
Or
But
you could do a whole
you apply that to space, and now you're getting real into like the nerdy weeds of mapping out anything.
Yeah, it would have to be a weird cross section of space too, right? Because it would have to be sort of like, rendered down to 2 dimensions.
and
You know,
You'd
also
have to
constantly
a
expanding.
differentiation of axes. I don't know. How
think
would we
about
even do
all
that?
the different shapes that you could make in 2 dimensions,
Yeah, that's true. That's very true.
all the different orientations and all of the different styles of making a map. And you wander into some like really nerdy rabbit holes real quick, but interesting.
Oh, I think we should do that. And we can focus on longitude and latitude because apparently the introduction of those 2 concepts made big waves in the science community back in the day. But, thanks to answering that question because, about your experiences kind of witnessing the stars and thinking about it for the first time, because just like individuals, and as we were talking about, our civilizations, they've had their own encounters with the celestial realms. And I was looking back, like, how far did this go? It seems Mesopotamia has some of the earliest sort of recordings. They have these inscribed stones and clay writing tablets dating to 3000 BC. And, it had some of the earliest evidence of humans' identification of constellations. So it's like you go from observing something with your eye to wanting to keep it. And I think having some of those early records, you think, as we built upon that, it's when you start to realize, like, oh, there's seasons, there's patterns, these constellations reappear, and you see things develop. And I have a note here. So between 1508 and 1514, Polish astronomer Nicolaus Copernicus announced that the planets revolved not around the Earth as everyone believed, but around the sun. And he said he watched the skies with only his eyes since 100 more. Wait. Oh, yeah. So he did all of his observations just with his eyes. He didn't have a telescope. And I was reading a little bit about him, and I was wondering how much smaller the universe would have felt. If we had no knowledge of other galaxies, and night after night you look up to the sky and you just saw these things shining down with no clarity as to which ones were planets, which ones were, like maybe galaxy clusters or something like that. And I was just trying to imagine, like, like, can I take away all my modern knowledge and just be like an observer back then? And would it feel like a small universe? Do you think? I don't know. Does anything come to mind?
Well, it would make sense that as our knowledge expands, so does the universe, right? So, before we started really thinking about a lot of what's out there, and working with math to figure what that was, people thought the Earth was flat. People thought we were in the sort of like a snow globe or a domed plane, whatever. So yeah, I think that the expansion of space continues with the knowledge of space, and so it would make sense that the universe would feel much more intimate with less knowledge.
I don't know though. Look at our universe now. If you live in a major city, go outside and look up at the heavens and tell me what you see. Is it so expansive? There's like a few dots in the sky, right? And by intimate, I find like trying to reach for beauty. And like currently, I feel like we almost run into the same problems it's very localized in the sense that we don't see so many stars out in the sky anymore, and it like has robbed it of it's robbed
Awesomeness.
it. Yeah. There's a lack of awe in the thing, but there's like that goes into like the lack of wonder. And then back in those days, if you just had your naked eye, that's without light pollution, that's what you saw every time. So it almost runs into the same issue of like now we have a very small localized knowledge base because that's what's expected. But if you kind of change one variable, then everything kind of changes. But if you have this one observer who's seeing things from a different perspective on the same set of data as Copernicus did, I don't know. Maybe there's still hope uh, for at least the acknowledgement of the observable. Like there's some hope that even with our limited like star gazing ability, that we can one day strive to become astronomers or something, right? Like, even though it's not really breathtaking anymore, it just looks like a bunch of dots in the sky. For the most part, you ignore it. Right? If you go out, you look at the moon, you don't look at the stars. But there's still a hope that it can still capture some people.
Hmm.
And I feel like that was sorry. No, go for it. I'm just gonna start rambling at this point.
You sure? Okay.
Yeah.
Okay. Well, so it gets interesting because this next little bit of information is about Tycho Brahe. I don't know if I'm pronouncing that, but he was a Dutch astronomer who actually observed a supernova in 1572. I didn't have time to look up how rare this observation is, but like no time in my lifetime do I remember anybody being like, "Oh, if you go outside on Tuesday, you'll witness a supernova." And what was interesting is that he witnessed that, thought it was interesting, thought about it, and he really shook things up during a time where it was common for scientists to think that the heavens couldn't change. But he actually witnessed this supernova and he realized things in the universe can and do change. And that was like another little, to me, significant shift in what we know and challenge, maybe.
Yeah. I think also the concept of the impermanence of what we do see as our night sky, right? I mean, most of what we see has already gone, which is its own other discussion that bothers me. But like if you think about the way the North Star has been positioned in our modern era, that wasn't always the case, and the North Star will change again in the future. So you can think about like the way constellations rose and dawned and setted. All of that would have been different over the span of thousands of years, and so yeah, it's interesting to think that the thing that you're studying will be constantly changing over long periods of time too.
Yeah, totally.
And there's a whole latency effect, right? The thing you're seeing isn't happening right now.
Right.
It happened a long time ago. But imagine being able to, because like, what's the probability of a supernova happening within naked eye shot?
Right.
Even for that time, I imagine it's a little low.
It would have to be. I mean, and I mean, well, maybe not. Is it? I guess like
are there
the infinity of space
all over the sky?
maybe we just don't see it. I don't know.
Well, that's what I'm saying. I never have seen a supernova, and I kind of feel like, to what Mike was saying, here we're so sophisticated and we're losing stars because of light pollution. So we might be losing our access to the like natural events like that, which could be kind of important, especially for inspiring future astronomists.
Yeah, I think the even outside of astronomers, the job of the heavens is to humble you, and in our weird um, uh, Tower of Babel sort of way, we've rejected the humbling and made ourselves appear much bigger than we actually are.
We rejected the humbling. I love that.
In our opulence, we have basically put our thumb in God's eye
Yeah,
by
I'm a little
blocking
worried
out the
about.
stars.
Yeah, I'm a little worried about like falling into like flowery poetic word salad. That's not something I want. But the truth is just like if I don't know if you live in Los Angeles, you can look up in the night sky and see a supernova. Do you know how close it would have to happen? You would probably feel it before you saw it.
Well, apparently, I finally looked it up. So supernova, novae, I guess is the plural form. They're visible to the naked eye very rarely. One occurs in our galaxy every few hundred years. So there's no guarantee you'll see one in your lifetime. However, there was like a a supernova called 1987A that happened in 1987. And apparently, an odd type of exploding star called a red nova is going to appear in our skies this year. It'll be the first naked eye nova in decades. So that's some serendipity, listeners.
Finally.
Yeah,
It
finally.
only took a few decades.
Right. So yeah, no, I was reading through things, and there's this great quote from Rene Descartes. He says, by taking our sense of sight far beyond the realm of our forebears' imagination, these wonderful instruments, the telescopes, open the way to a deeper and more perfect understanding of nature. And so we get into the birth of the telescope. And I like the way that he says, it's, before we were limited by imagination, which can be really creative, but it's only until you can like observe stuff with these new tools that you can start to imagine even more stuff and things. We gain more knowledge from there, which is awesome. I mean, maybe that's not the only way, but it's interesting. And I do think it's kind of funny getting to that curved lens. So the earliest known telescope, it appeared in 1608 in the Netherlands because this eyeglass maker filed for a patent to make a telescope based on refraction. And that's like the first known appearance of it, but he didn't even get his patent approved. So that's super sad that he's known for the guy that like almost invented the telescope. So shout out to Hans Lippershey is his name. And it's worth noting that the Mayans and the ancient Greeks used observational techniques and calculations to monitor and predict orbits and eclipses and things like that. So I think getting onto the telescope, let's see here. So this idea of the concave object, the lens, and the eyepiece, from what I understand reading about the Webb, the concavity of the lens allows it to hold more light, and that gives you a better picture of what you're looking at. Galileo improved on the design of Mr. Lippershey, and he made fundamental contributions to astronomy and to the development of the scientific method. And he made revolutionary telescopic discoveries. So he was the one to first find spots on the sun, and he found 4 of the largest moons of Jupiter. And those of you who, probably follow this show would be quick to note that he was also ordered to turn himself into the Holy Office to begin trial for holding the belief that the earth revolves around the sun, which was deemed heretical by the Catholic Church. So I just think it's funny to think back on, like the Da Vinci Code kind of stuff and these little beginnings of the church versus like the science. No longer do we have the witches or the demons, but we have these like modern day inventions and discoveries that shake things up. Instead of a static universe, we have all this change. And I'm just curious, like, What do you guys think about Galileo? What do you think about why they would have been threatened by his discovery?
Well, I mean, you have a whole way of running societies for hundreds of years that would have fallen apart, let alone faith. Yeah, faith is a big underpinning. Like, you prove God wrong, and all of a sudden, yeah, you have to kind of think about the way you're structuring civilizations, even just all of it. Because around Galileo, like the height of theocracy, you can argue, height of religious governments just going crazy for whatever they feel is in the moral right. And to be Galileo is, of course, to be a rebel. It's akin to be something like Jesus. Just go against the grain and have evidence to back it up. My big worry now is that we've found a way to put faith into science. In science, you can have faith, but you better be a scientist trying to figure out the first reproducible experiment to something. But nowadays, it feels like science has scientism. It's become a faith. It's become a religion that should be pressed back again. So I think there needs to be more Galileos.
Well, and I wonder how much of that too is like the delivery, because I remember seeing this great article, and it was about like how often you'll have an article that says like, according to science, but it's like we need these short article titles, but the proper article title would be, according to this one dissertation that's under peer review that was published on this date and has these limitations and these statistical anomalies, we have found that there is a slight statistical significance to suggest. And so you can like get granular with it, but yeah, I think you're right. Like, there's always that balancing act of kind of juggling rigidity and openness, maybe.
Well, it's just, yeah, I mean, you can say that as far as like a civilization building. Allowing doubt. Doubt is very important, no matter what your faith is, even if your faith is science. Because if your science is science, then you have plenty of room for doubt. But if you don't, then it's become your faith.
Mm-hmm.
Rigidity and balance. What would you say before finding the balance between rigidity and openness?
I guess I was just.
Headlines. So data compression. Sorry. I reminded you, and your thought reminded me. We run into a problem of lossy compression, especially while we talk. Lossy compression is just the loss of valuable information whenever something gets compressed. What I pull it from is from compression of files. So whenever you put something in a zip, usually it's lossless, meaning no crucial information is going to get lost. So if you zip a file or a bunch of files, you know that once you unzip them, they're going to be there. But what happens in those headlines that you're talking about, where science says this, is that there's some level of compression that happens to get people to click on it, where they don't take in the limits of the article, they don't take in the proper parameters that needs to be set up for some sort of data compression, so that the headline is catchy.
Okay. No, that's a really good point. And I think when we get into the Webb Telescope, and for those of you listening, I'm kind of hitting these interesting little points because we're going to circle back to them once we start talking about the Webb Telescope. Nick, did you want to add anything about Galileo and anything there?
Ooh, do you think data compression got Galileo killed?
I think that's a great idea for a book, like series, like the big bad data compression factor.
Because he has to like defend his own case eventually. And there's no way that he can explain everything in the way that he would want to without losing listeners or without losing people in the Inquisition, in the court.
I'm not sure what his. Let's see. I mean, I'd have to look that up, but yeah, no, yeah, he'd probably have to advocate a lot, and it'd be hard to communicate.
Like he would have
Like
to
brain
change,
dump.
like he would have to change his whole theory into one that has a basis in God, and that becomes very difficult during that time to do on the spot. I feel like just to get within the same language set, like getting the same set of words to use, so that the other person can understand what you're saying.
Yeah, no, and that's a very hard thing. I think, settling on terminology is super tough, and especially if you're positing information that's going to sort of like rock certain established thought. Yeah, that's going to be super hard, especially trying to communicate that in like a neutral way for like a trial. Yeah, I don't know. That would have been, I don't know. Would that I were a fly on the wall at that time, to hear him speak.
And you find out Galileo is just a really bad code switcher. Just can't switch codes on the fly.
Mhm. Right, exactly. But so moving on, okay, so I'm gonna skip a couple of things. I wanted to talk about this is like obscure moment in astronomy where in 1981, you have Roland Christian of astrophysics creating the first color-free refractor lens. And I like the idea of color being something that would change the observation seen from the telescope. I think it's kind of a good idea to talk a little bit about discoveries and instruments. I think we did an episode on color, did we not? Or was that just sound?
I think it was Lights and Sounds.
Lights and sounds. Okay. Was that your episode, Mike?
Fuck if I know. Sorry.
It's been a minute.
I don't know. It's been some years.
Okay.
Somebody's episode. It was one of us threes.
One of us threes. Well, okay. So, okay, let me read this little thing. So this is on characterizing stars. You've got Danish physicist Niels Bohr showed us that the orbits of electrons inside atoms are also quantized. They come in, promise this isn't as complicated as it sounds. They come in predetermined sizes called energy levels. And when an electron drops from a higher energy level to a lower energy level, it spits out a photon with an energy equal to the size of the gap. Equally, an electron can absorb a particle of light and use its energy to leap up to a higher energy level. So astronomers use this effect all the time. We know what stars are made of because when we break up their light into a rainbow-like spectrum, we see colors that are missing. And different chemical elements have different energy level spacings. So we can actually work out the constituents of the sun and other stars from the precise colors that are absent from those captures. And I didn't know that. And let me know, does that make sense to you? Like, it's this idea of like deducing information. We look at something, we're like, oh, we realize that this matches this. And so if that's missing, we can infer blah, blah, blah. And I think that's just like super cool.
All hell the noble gases. I think they have different colors when they at different temperatures. There's a lot of like neon lights. You mix a couple of different chemical elements and you get a new color. That makes sense.
Yeah. And I thought I was bringing this up because we were talking a little bit about this episode last week, and Nick had brought up sort of like an issue that was bugging him. And it was that this idea of telescope image capturing and how it's data, and then it gets compiled into these beautiful pictures that we see. Nick, did you want to kind of expound a little bit on that?
I said that as a really flippant comment, so I don't really want to continue on about that. I was just remarking that, it's interesting how all of that data is compiled and then rendered for us to see an image.
Yeah,
There's a-
I mean,
Yeah. That's the extent of that's the extent of it. Sorry.
No, there is a bit or a heavy bit of image processing that happens with those. It definitely affects the way that you see the universe, which might either be proper or misleading depending on who's doing what behind the scenes.
Yeah, and also like with the Hubble telescope, they take photos of space. They use filters to record specific wavelengths of light. Later, they add in the red, green, or blue to color the exposures taken through those filters. And the result is these full color images that have a variety of purposes for analysis and stuff like that. But Mike, it just makes, I don't know, when Nick mentioned that, it was something I hadn't thought about before. And I was thinking about the data compression that you were mentioning earlier. And I just got thinking, like, you know, yeah, I'm just marveling, I guess, at how incredible it is that we're able to build stuff that can go, millions of miles away or thousands of miles away and capture information and then send it to us and we unpack it. Now, is there room for error? Absolutely. Could data compression be an issue? Absolutely. But it is pretty cool when you start picking apart what's at play. And, for listeners, if this is interesting, you can deep dive it. We'll be moving on in a minute. But I just wanted to share that because Nick brought it up and I thought that was a cool thing to think about.
It definitely is. There's some questions from multiple angles. Like from a color science point of view, what kinds of reds, greens, and blues are you bringing in? First off, there's two different ranges that work within typical entertainment. One that's supposed to be representative of analog TV. So when they were sending actual waves into your rabbit ears, into the antennas, that would be broken down to color information. And we have a certain scale to represent those colors. And then there's a whole other scale that represents the way that computers render red, green, and blue. And then you can get the same effect with a whole different thing, with whole different, color space. They call it with YUV, which is different from red, green, blue, but produces the same colors. That's one side of the conversation. The other side also, too, is compression. And I'm sure in the past there's a lot more compression there is now. You have a question of things correcting errors as information comes across. So when you send data back and forth across a network, whether that be through a wire or through wireless, you're going to have an error. You're going to have electrons that jump from wire to wire, or you're going to have electrons that just jump out of your wireless process. You have to correct those errors. So which you might also, there is a chance for corrections happening when they don't need to happen, but that sort of computer science pretty solid. I feel like the image you're seeing is half of whatever artist wants you to see as far as space goes. I don't think it's an accurate representation of what's actually out there. And then the other half of it is, the errors are being handled properly when transmitting that information over, or they're being overcorrected or undercorrected, or if some sort of lossy compression is being handled. Mm-hmm. All of these like weird variables build together in like this beautiful image you see.
Yeah.
But that may be over exaggerating.
Yeah, and it's something that if I've seen some of the Hubble images, there are moments where I'm like, is that really what it looks like? Or is that like when we get dinosaurs wrong? Like we assemble the bones and then like 10 years later, we're like, oh, it had a wings or it had feathers or something like that. Eventually we might find it's wrong. It's probably pretty close, but they are very beautiful that you're like, whoa, what is this? Is just like, I can't even really wrap my head around it sometimes, I think.
Those are the pictures you show when you need more money for research.
That's so true. That's so true.
We need more money. Look at these pretty fucking images.
Seriously.
That's what's out there. Let's go get it.
Let's go get some.
He gets all hyped. Like, yeah, bring in more money.
Yeah, absolutely. Well, and it's interesting because there's like this concept where you have the equipment that's out there observing and gathering real data, and then you have like the human mind, which just figures stuff out. So in 1846, Neptune was actually discovered without ever having been seen. Two astronomers, John Couch Adams and Urbain Le Verrier, inferred Neptune's presence. As its size meant that it had influence on the orbit of Uranus, they were observing like unusual orbital patterns. And then it wasn't until John Gailey pointed his telescope in the direction that they were suggesting and discovered there's Neptune, which personally I think is like the biggest intellectual flex ever, because you weren't psychic about it. You just knew some facts, made an inference, and then told some peasant to prove it for you. And it's just like, that's crazy that humans can do that. Like it boggles my mind, you know.
That's like
Cool.
like you're trolling somebody, but the troll actually is real. Like you put together some inference. Yeah, you put together, like you said, you just said the thing. You made your friend go do it, and then your friend was like, "No, you're actually right." And you're like, "Oh shit."
Exactly. You're like, well, you owe me $10. Well, cool. So I can get into the Webb telescope now. Thanks for indulging some of those little ground laying facts. So let me actually start with the color thing. Nick, are you able on your end to, if I send you a link to an image, can you pull that up on the screen?
Yeah, I should be able to. Hold on.
For those of you listening, what I am pulling up or asking Nick to pull up is an image from NASA, and it just highlights the electromagnetic spectrum. And it highlights that the Hubble telescope, let's see.
Almost there.
Almost there. Okay. So it's just it shows the spectrum. It starts off with gamma rays, X-rays, ultraviolet, has a very narrow sliver of what the visible eye can see. There it is there. Then it gets into infrared, microwave, and radio waves. And you can see on the bottom level, it highlights that the Hubble telescope can see some ultraviolet and a lot of the visible spectrums that we can see with our eyes. But the James Webb Space Telescope is primarily focusing on infrared. And this is part of why it is such an exciting new tool that we have. So let me just go back to some of my notes here. So I guess first thing about this is you guys are talking a little bit about like, and Nick, I'm sorry, I'm going to break your brain just a little bit. Watch out. So apparently as things get farther and farther away, the color turns more red. And I have a little like spiel about why that is. It's super freaking creepy. So the Webb is an infrared telescope. It captures light that's more red than our visible eyes can see. Red has longer wavelengths, lower energy, so it's lower frequency. And this is part of the concept of red shifting. So we know the universe is expanding, and we know that because scientists look at the quality of light coming from different parts of space. It turns out that things farther away from us look redder than things that are closer to us. This concept is called redshifting. It's key for astronomers, and it can be understood literally that the wavelength of the light is stretched, so the light is seen as shifted toward the red part of the spectrum, right? Because if we're observing something that's far away, the time that light takes to get to us, it takes time, and time's expanding the universe. So it's kind of similar to like an ambulance, if it's coming up when it's far away, it's so you can hear it, but then as it gets
Doppler.
closer, the pitch increases. It's kind of the same thing with this redness. And so what's really
that's how they proved that the universe was expanding.
Mhm. Yeah, and as light travels from distant galaxies, light's literally being stretched from the expansion of space. So a star, it has to get to us, and as that happens, the light drops into that infrared. Now, Webb can see that, and we're going to be seeing stars that no humans ever seen before, simply because of the technology that it's using, which is very exciting. This is putting us back to like, first seeing, uh, Pluto, or first seeing Saturn, first seeing like
Yeah, we'll
everything that it brings back is just going to be new, new, new. This is exciting.
find a space Cthulhu trying to eat the planet Earth. Then I'll be real happy, aren't you? Oh, look new tech. We saw things we couldn't see before. Oh, that's really what's there. Okay.
Right. Or ancestral wisdom's going to be like, y'all know what we think about the color red, right? Like, there's a book about how it's associated with not good things.
Turn it off. We don't need to look at that. Turn it off.
Seriously. But I did think that was interesting about this idea that the light dips into this infrared range as it gets older. Part of why people are so excited about the Webb is that they're hoping they're going to see stars that are almost as old. Yeah, that are going to be like closer to the beginning of time from way back there. It's so hard. Yeah, you're looking at stars in the past that are more proximal to the Big Bang, but not like
That if you were able to travel to, wouldn't be there.
right. Right.
Which makes sense.
Yeah, no, I mean, I think it's pretty cool. And one of the other cool things about the Webb telescope is it's ginormous. The Hubble telescope, which we've been getting a lot of data from, it is about the size of a school bus. But the Thomas Webb telescope, it's like 4 stories tall. And I didn't.
Size of a proper school bus or like a short school bus? That was a school bus I got.
Proper.
Oh, proper one. Okay, not the short one.
Mhm.
All right. Thanks.
Yeah, and it's for the Webb one, it's about 4 stories tall, which is crazy because we don't have rockets that could launch it. So they had to literally take it apart and like fold it up or something, stick it on a rocket, and it's like assembling itself by itself in space
Mhm.
over a period of time as it floats out there.
Mhm. You can dissect things into like 3D grids. Just because they're vectors doesn't change them from 3D grids. Now I don't know if like some sort of like satellite trash floated into like the construction area. I don't know, could adapt for that. But it makes sense that that's how megastructures would be made in the future. You launch out off all the components and have a computer program pull them all together.
Yeah. Yeah. Yeah, I mean, it's one of those accomplishments of humans that's like, again, really hard to fathom that we were able to put this together and get it to put itself together. And I know that they're still working out there's a couple more benchmarks to make sure that it's all fully assembled, but it's still pretty cool.
Nope,
Um,
nope, we're slackers. This is not good enough. We need to push further, faster, stronger, better. What's
better.
the Daft Punk song?
I knew where you were going. Yeah, and part of the reason it's bigger too is that it has a mirror that's like super huge compared to the Hubble. So it'll be about 100 times as powerful. And it's actually going to change the way we see the universe. This means exploring new worlds, understanding the origins of the universe, and even, yes, searching for life in the galaxy. These are all mission objectives of the James Space Webb Telescope. And of those 3, is there one that either of you find more interesting? Exploring strange worlds, understanding the origins of the universe, or searching for life?
I don't know. It's a good question. What I like more? I mean, it would be interesting to try to get closer to the beginning of the universe. I think that would be pretty noteworthy. But again, I guess, yeah, you could just take pictures of what's closer to the center, but I guess that would take a very long time. So probably looking for life might be a better short-term answer.
Thanks. You're probably right. I only say origins just because I want to turn God into Bigfoot. And so while we're taking all these really old pictures of the universe, like, oh, you see that little outline of a shoulder and a face? That was God right there making that star.
Mm-hmm.
Ooh, I see you. I see you. But like millions of years ago. So
Yeah.
he could look totally different today. That's old God.
Yeah, it's old God.
I
Like
see.
Bigfoot. He likes old Bigfoot. You know what Bigfoot looks like today.
Yeah,
Bigfoot could be playing in the NBA. We wouldn't know.
that's true. Yeah, absolutely. Well, and there's actually, so they have like open source grants that anybody can apply to try to like access data and do research. It's pretty competitive, but I do know one grant was approved, and it's this researcher. She is looking at a very specific planet that's known as like the lava planet. So apparently it's really close to its sun, and it has like all this type of like lava on it. Like it's pretty much all lava. If you tried to get close, you would burn up. But they want to hone in on it for some sort of like atmospheric collection of data. But it's crazy to think that like I've never heard of this planet. I don't know how far away this planet is, but we have the telescope now to like zoom in on that pretty well now. So that's, I don't know. I'm pretty excited about that and all the other planets out there, to be frank.
Do you know where they're positioning this telescope?
Yeah,
Is it
it's
going to stay in
interesting.
one spot, or is it actually going out further into the out of the solar system, like Voyager or whatever?
Yeah, it's going to be orbiting the sun. So it follows a path similar to Earth. Let's see. I had a note about that somewhere. I'm not sure if I can find it. But it is kind of interesting. So it's going to be like 1,000,000 miles away from us. It's like the distance of like 10 journeys to the moon. So it's super far away, but it stays within our like we can still like see and access it. I'm guessing for like satellite data transmission and stuff. And then it's kind of like a moon that's like super far away from us. So it follows us as we follow around the sun.
Mm-hmm.
And yeah, so it's just cool because it's going to be super far out. It won't have any light pollution, and there is something specific about the way it's going to orbit. I don't even know how they were able to control that orbit. I think once it hits like a certain like gravitational point, it gets like floated around or something. Maybe.
For reference, Mars is 33 million miles away, so it's actually very close in the grand scheme of things. It's only a 90th of the way to the sun, anyways, right?
There it is. Yeah. Well, Hubble, for reference, is 340 miles away. So if
That's
Webb
not
is
far
a
at all.
million, yeah, it's again, this is why people are so excited. Is it's bigger, it sees farther into the past, and it's going to be a gazillion times deeper into space.
We need mass-produced telescopes of maybe a little less quality, because once the aliens start to invade, we have to figure that out way before it happens. So if we get enough of these telescope scouts out there,
build the wall in our solar system. Is that what you're saying?
Well, I'm just saying, like, these all sound like
Oh God.
tigers and panzers of telescopes. Maybe we should, set out to make some Shermans and mass produce them and then just send them everywhere. And just see what happens with that, and then keep building our little tiger telescopes over here. And going further back in time and finding, origins of the universe and all that fun stuff. I'm just more worried about an invasion than I am about this stuff.
Oh, well, if you're worried about an invasion, I think you should be worried. There's like a team of scientists. I don't know where I heard this, but they like shot.
No, I'm just kidding.
No, they sent some sort of like light beam out into the universe to like call attention to our planet and seek out life. Did you guys hear about this in the news?
I've been doing that for a while now. I don't think
Oh
it's a
my
good
God.
idea.
Yeah, they've been doing that. Sending rays out all the time.
Yeah, I think it was like Hawking who was saying that, if there is intelligent life, it's likely more powerful than us, and the only thing saving us is that they haven't discovered us yet. So don't call attention to yourselves. Don't do it.
Well, my question is if, like, so you have planets without life on it, right? With a certain gravitational pull. I'm curious if Earth can have a different gravitational pull because there's life on it versus non-life planets. More mass, more stuff there of equal sizes and all that, controlling for all the rest of the variables. Because you might be able to find a way without seeing life to like make a life signature, just by its mere presence if it's heavy enough.
Interesting. Well, I do know that like our planet with life emits more light or something. There was something I read about that. I didn't think we were going to get into that, so I didn't save it. But there was some information about how this telescope would be used to observe life in other planets, and that was kind of interesting too. But that could be tied into some second Alien episode or something like that, because I know there was just some big talk in Congress about UAPs, and I'm sure Avi Loeb has some updates. The big nothing burger is nothing.
Yeah, unfortunately.
Unfortunately.
Yeah.
Well, so yeah, I mean, I could go on.
What do you hope, Ayla, that this thing picks up? Like, as somebody who is looking forward to seeing the images and stuff and information that we could possibly find out, what would be ideal in your perspective?
Well, I think that one of the biggest things is that it's not only able to look farther out into space, but it can also look further back in time. I've been kind of on this weird time kick, and so I feel like it's going to search for the first stars and the first galaxies of the universe. And even if we don't unravel all the mysteries, I do think that whatever data we will get, as it gets to be synthesized by physicists, philosophers, mathematicians, other different people, I think we're going to start to rethink these concepts that we've held to be such constants. And, that could really reinform some of our approaches or philosophies about, existence, the universe, how we began, and especially too, like when you think about, black holes, for example. We've got the first image of a black hole a couple years ago. The Webb telescope's going out there. Scientists are already working on like an even better telescope to send out there. We're going to start learning about that. And in those cases, they unravel certain things. And I think that's really important to back inform, how we understand things on this planet and get more of that like geogalactic experience maybe.
Yeah, I don't think that's wrong at all. I think a step in that direction is probably good progress for humankind. It'll be interesting to see the images. I'm very interested to see like what we get to sort of spy from that distance, especially considering Hubble is so close. I did not know it was that close. So 1,000,000 miles is much more than 340 miles away. My second question to you is, do you think that what we should do is put another telescope in front of the James telescope so that the James Webb Telescope is looking through a telescope? Maybe that would maximize our view into the universe.
And then we can
just keep going from there. It's just have a long line of telescopes skew further and further back.
That
Well,
sounds
I'm-
like a telescope.
Yeah, just a telescope, but with more parts. And
right. Well, I'm surprised you didn't pick up on like the use of mirrors in telescopes earlier, because as I was
I had ginger
researching
tea, and it just I just need to stop drinking ginger tea during episodes because it goes right through me. Sorry, guys, TMI. But I missed that part.
Oh, it was just a simple thing, but like while I was reading, I didn't realize that mirrors were a crucial part of telescopes in terms of like, taking the refracted light and funneling it so that you can see it. And, the concept of a mirror, if you want to get kind of more like esoteric about things, it's ripe. There's a lot of lore around mirrors, and also this flip-flopping of images. And I don't know. I thought you would have chimed in.
The geometry, just the geometry alone. You can set up a sequence of mirrors to see around corners, to see at right degree angles. You know what I mean? Like, it is kind of cool that that optics can do things within, a set of, angled mirrors that we would normally not be able to do. So yeah, it's pretty interesting stuff. You think of like a periscope, right? And it's like you're looking straight ahead, but you're seeing up and straight ahead at the same time.
Now, imagine if those mirrors moved based off of some heuristic.
If they move?
If they move within the optic system.
Okay. Yeah.
Maybe 360 images or something.
Be unstoppable.
Like
Well,
180 images.
those are things that it already does to like try to bring in the most light from some whatever angle. Like, I'm starting to think about your telescope on top of a telescope on top of a telescope.
Yeah.
Idea. Like the nth level. And you have to have mirrors that move the way to bring all the light in so you get all the magnification you want. Right? Because like you have one lens, you could zoom in a certain bit, and then you have another lens at front of that you could bring in more. Maybe bring in mirrors and you start to bounce around light. And if you have those mirrors move, then you can optimize for the amount of light that you're trying to bring into the whole system, or regulate when you have another telescopic system on top of it. So you have like this whole hive network of telescopes.
Yeah, we're destined to clutter our solar system. It's gonna be full of stuff.
The problem with telescopes to me is that they're always like, what's the next biggest one? Like the telescope only looks at one angle. We need more.
Many of them.
Like a bunch of them at an adequate, like whatever you feel is adequate, and then send them all out there.
Never mind the fact that if there is an asteroid that comes to us from underneath us, we're effed. It's like we have no telescopes looking at above us or underneath us.
Just all out on the sides.
Just out on the sides. Yep.
Do you know how hard it is to launch a rocket from the North or South Pole?
They can't do it. Yeah.
Wait, is that though because like everything kind of spins in like the same direction? So it would be unlikely that because if something came from the top or the bottom, wouldn't it just get sucked into the orbit? Or is that wrong? I don't know.
I don't think so. I mean, it doesn't seem like there would be any reason that an asteroid couldn't just, hit us on the top of our head.
Reasons.
Why not?
Well, it's
space
interesting.
Goes in all directions. So.
Yeah. Well, it's funny to think about like this transmission of light, because something that I could do more reading on is the wave particle duality. Have you guys heard of this?
Sometimes something acts like a wave and something acts like a particle.
Yeah, pretty much. So J.J. Thomson won the Nobel Prize in 1906 for his discovery that electrons are particles, but his son won the Nobel Prize in 1937 for showing that electrons are waves. So it's like, who was right?
Are we sure this isn't a scam?
I know, right? It's like
now it's both. Sorry.
Yeah, to all father and son duos,
we owed that family a favor.
You can't beat these two.
All depends. Where and when you look at it.
Mm-hmm.
How do you look at it? You look at it sternly. You're looking at that like fucking electron. You're like, oh, hey, electron, how you doing?
Yeah, if you're friendly, it'll wave. If you're not friendly, that's when it particulates.
Yes.
Yeah.
Particulates. Oh man. But yeah, no, I don't know why. I was just thinking about how it would be interesting to read a little bit more in the quantum physics side about wave particle duality, because it applies to light as well as electrons. And sometimes it pays to think about light as an electromagnetic wave, or other times it's more useful to picture it in the form of particles or photons. And this gets into like the Higgs field stuff. Higgs field, just like that guy who was like, "Oh, the orbit of this planet is off. There must be another planet there." A lot of physicists were like, I suspect that there's some sort of field out there that's doing things, and they proved it with the Higgs boson particle, I think or photon. I don't know maybe it was both, but I think that like we're starting to get all these common terminologies. These disciplines are starting to nail this down a little bit more. And I think that like introducing infrared technology is just going to help us get better at our estimates and what we do. For example, like Hubble, one of its big things is measuring the expansion of the universe. It's an evolving number. It's something like if you look at the rate of expansion, I think there's like a term for it. It's constantly being updated. And when you think about like
Planck's constant.
That's it. Thank you. And going back to thinking about time, like as errors that are like a fraction of a millisecond to the 10th sub n or something, right? Like if you take that error and you zoom it out a million miles, that error gap ends up increasing exponentially. And so I'm just again thinking about like, how things are going to sort of shake out once we start to get more accurate readings and we integrate that into what we already know. That's the biggest crux of this episode is
the hallway
Yay.
will stretch and we'll say if we can just get over there, then we'll really know.
Then we'll really know.
That's that's the ever living pursuit of knowledge, right?
So
it's radio waves.
Have you taken any interest in like Wi-Fi?
I'm using Wi-Fi. No, I'm just kidding. Wait, say your question again. Is it
Same idea, but using light instead of whatever the hell we use for Wi-Fi now?
Radiation.
Yeah. Same idea, but you encode light. Problem is that if I stick a piece of paper within a beam of light, then you lose all your internet access. And it's kind of hard to put that into like a cable that can just transmit light without affecting it in any way or form. What is kind of interesting is maybe if we can encode IR with information, then we might be able to send it across galaxies in a like a lossless way or something. I don't know. Encode this new spectrums. The thing that I don't want to see it become though is let's take IR and plant it on the red spectrum, or let's take ultraviolet and plant it on the blue spectrum, so that people can see what this stuff looks like within red, green, blue. Because you're like trying to like quantize something on two mismatching spaces. I guess it could be done, but it would be real messy. There's a lot of information. But it like I just worry that all of this is going to become just a novelty. Like, look at the IR light. Isn't it crazy? Wow. It's like, yeah, space does that. Those are those things out there, but now we can see them. Like, I feel like it just has to be something more than like a scientist just getting his or her rocks off on looking at IR. That's what I worry.
Well, if it helps, it's just thinking about like contextualizing some of this. So with the Hubble, it sees light dating to about 400 million years after the Big Bang, which took place about 3.3 billion years to reach us, or which took about 13.3 billion years to reach us. So the Webb has the capability to take us to 250 million years after the Big Bang. And I think that closing of that gap, if you can wrap your, because I say this, but I still haven't really sat down and thought to myself, like, okay, what is that saying? And I'll repeat this again. Nick's looking like confused too. Hubble has seen light dating to about 400 million years after the Big Bang, which took place about 13.3 billion years. Sorry, I keep messing that up.
It took 13 billion years to get to our eyes.
To reach us. Yeah, exactly. So we're like having some of that, or shortening that with our telescope. But the Webb has the capability to take us to 250 million years after the Big Bang in terms of what we will be able to see and observe. So, you know, if it was like a difference of 400 and 375, then I would concede that, yeah, this is just like scientific giggles. But that's a significant gap to
point.
jump.
Why? What are we going to gain outside of a historical record?
Well, I think all you have to, I think just look at what discoveries have been made since we launched the Hubble and then quadruple that.
Would implying that the Hubble was a part of every discovery since the Hubble?
Wait, say that again?
Implying that the Hubble was the reason for those inventions later on was the findings of the Hubble. Like that I can understand, where it's like if we launch this and then it gives us some new insight that we make all this new technology out of, and that works. Like that would be dope. Like that sounds fantastic to me, but I don't know if that's true.
Oh, okay. So I think you're just getting back to its core missions, is exploring strange worlds, understanding the origins of the universe, and searching for life. I think perhaps having the presence of an interstellar object made it something that was more of a viable thing to get funding for, searching for life. Perhaps as we continue to destroy our planet, it's important to see about those exoplanets, see if there's other humans out there. I mean, because you have to think about it. Like if there was a Big Bang and everything scattered out, if you assume not even distribution, but there's like a term,
asymmetrical.
Yeah, well, like in the sense, uniform field theory, right? That idea, like if you look in one direction of the universe, you can assume it's going to kind of be the same in every direction because everything splooted out at the same time. So I think, yeah, like it's entirely possible that there could be human civilizations opposite us, and like if there are, maybe not human, but maybe some sort of intelligent life, like I want to know. I mean, that would rewrite everything. That would make us rethink a lot, including faith, including morality, including our.
But I don't think you'll be able to find it with just being able to see IR, unless you can pick up different things within those spectrums that tell you that there's life there, and then gives you records of their existence and parts of it. You know what I mean?
Yeah, yeah. And to that, I would just say humans and scientists are crafty. They'll be like, oh, this IR is like 20 seconds off of this IR, and this color gradient is less saturated, and we can infer blah, blah, blah.
You're mapping it on you're trying to map the uncountably infinite onto the countable infinite. And I worry that it may not work. I worry that we won't have enough space to encode the symbols that you're talking about with the symbols that we know.
Well, and we'd probably have to revise things. I mean, like, again, with time, right? Like, that's just as useless a term as high and low. And I'm quoting Carlo Rovelli here, who says that, like, if you're communicating to somebody and you're like, oh, this book is high on this bookcase, or look lower for the book, it's assuming that there's some sort of constant that the book is in relation to. high low doesn't make any sense if there's nothing to anchor it. And so I think that when we think about time, yeah, it's totally, schedule a meeting at 5 o'clock. You show up at 5, I show up at 5. We have satellites that tell our phones when 5 is, but that concept, as you get further out, it doesn't make as much sense. And I think when you start looking into like the nature of reality and knowledge, the further we get out, the more our concepts
slip.
And it helps us get to what would be what we're scratching at. It helps us get closer to truth with a capital T, because we start seeing where it breaks down and we can revise and go from there.
You're so hopeful.
I think.
You're so hopeful.
I try. Yeah, I'm excited. I think we're gonna find some cool stuff out there. I really do.
You're touching upon those really interesting ideas. You play within the notions of time dilation with something that can shoot out an IR signal, assuming the IR signal is lossless. So imagine you set up a colony planet where for every 1 Earth year is like 100 million years on their planet. And you let them run for, I don't know, 10 hundreds of millions of years. And then you tell them to shoot back to you a certain light signal that has encoded information, much like the Wi-Fi thing. Suppose because it could travel the furthest of like the slowest waves, as we've demonstrated now that if we pick up IR, we go however million years from the Big Bang Theory, which is much closer to when the Big Bang happened than whatever we can do now. So you just do a test planet, a test colony planet for a couple hundred millions of years. You shoot off this signal and it reaches us. And then we know not to either go, we know whether to go down that road or not. And I think that's where this stuff can be most interesting, is setting up communication networks where you can balance for time dilation of planets and play certain things out, play certain scenarios out. Like, what happened if this planet was completely autocratic? What happened if this other planet was completely hunter-gatherer? What were the things? And you somehow still have the tech to shoot like a predator planet, like predators.
So like you get to high school and they're like, all right, do you want to go to the predator planet? Do you want to go to the hunter-gatherer planet? Do you want to go to the pick? And they'll just shoot you out there and see which planet has the higher happiness factor or whatever.
Yeah, like you make a prison colony planet, you call the whole planet Australia, let it run for some hundreds, millions of years, and then get back the IR signal with all the information about what it's done. And for Earth, it's only been 1 or 2 years.
I hear you.
And it's a rapid way to accelerate information and knowledge. Because you'll eventually find some planet that does something great. But I just don't have, I think this is the first step that I'm building some system like that.
Well, are you talking about planet K2141b, which I just found out the name? That's the lava planet. Apparently, its clouds are likely made of vaporized rock, which could then precipitate rock rain. So it would rain rocks.
That just sounds like Mustafar.
It's pretty.
And Anakin are just fighting there forever.
Yeah, I mean, like that's the thing, I think, is that like we don't know what, like, there's the potential for us to see stuff that we have yet to imagine, right? So I'm thinking about like the supernova. I'm thinking about certain discoveries that weren't possible without the tool to observe them. And so I think for me, that's kind of where I'm hedging my bets. Pretty excited. I think it'll start to be like fully formed in another couple months, or it is fully formed and it's sending the images and it'll take time. But anyway, stay tuned. Keep up on that Thomas Webb news out there, because I think it'll be pretty cool.
No, I agree. I think it'd be pretty cool too. I'm just being cynical because it's what science taught me how to do. So it's not.
Well, maybe this will be the redeeming moment for Mike and his relationship with science.
If we get a signal back that says like, "Hey, idiots, do this all through IR," and then I'd be like, "Redeemed. Good job, science. You did your thing."
Redeemed. Yeah. And yeah, well, and getting back to the IR thing, like the light and the expansion of the universe changing the color of it to the point where we can't even see it. This was something that I was thinking about earlier is like, okay, so there's the Galileo moment, right? So he is saying stuff, it's running counter to faith, he gets in trouble. With the light, oh God, I just had it and I lost it. Okay, so this infrared light, it comes to us, the universe is expanding, it changes the color, so it takes it from something that's in our visible light sphere and it drops it into IR so we can't see it anymore. Now, Galileo's scientific method relies on our five senses, what we can taste and see and touch. We are now in this realm where we're making instruments to observe things that our eyes can't see, but we can extrapolate the data and then make it something that we can see. And I think that this is a really interesting philosophical crosshairs because it kind of like, yeah, it's weird. It's like transcending sense-based knowledge in a rational way.
You and Camus would agree with each other. Like what he says in the Myth of Sisyphus, right? You talking about the atom, talking about the particle, you drive me back to poetry.
Mm.
Nothing scientific because I can't observe it myself. And that's maybe a little bit of danger, right? But if we have instruments that can actually do it, and we can test and we can trust them as we trust our senses, I don't see why we can't push forward on the ideas.
Yeah. Unless there's some sort of weird IR issue or data compression issue or
Like, yeah, that's where the raw sensors get really interesting. You can build up infinite space, but keep it within that infinite space, and the image is gook, then the image is gook. I feel like you got to get your numbers right before you get your composition right.
Yeah, absolutely. Especially in this case where you're trying to like use the data to create images. And I think that's definitely, that's something that I wonder about because, for example, like if Planck's constant isn't that constant, and if the universe is expanding at a rate that we're not 100% sure of, and there's this room for error, and we would have some error 320 miles away. Imagine that error a million miles away. You know what I mean? Like, I'm just saying that, like, I think it's I think it's interesting that we're going to have these images that are going to be coming out of a area that we cannot see with our own eyeballs, but we're using our tech to be able to extract all this data. There's room for error, and it's getting in that, like you were saying, the Camus poetry sort of phase, because you don't know until you know, and it will get us closer to knowing, absolutely. But grain of salt too. Like there'll just be a lot like a big learning curve, I think, which would be good because it's a learning curve upward.
One would hope. I don't know if we can make the sensile response. I'm trying to think of like if there's some sort of combination of synapses that you can fire to be like, oh, that's infrared, and that's completely unique. It's not like, oh, it's a goose, or maybe it's infrared. I feel the same thing. My brain does the same thing whenever it touches that thing that it's responding to, that signal. So that's like the hard part. Like you said, like it's trying to stay true to whatever it actually is we're trying to observe that we cannot observe, which is poetry, really. But yeah, do that in a scientific way is extremely difficult without chopping your own legs out from under you during the process.
Yeah, right. I mean, it's the same thing with butterflies, right? They can see color fields that we can't see. They can see ultraviolet. And so it's like, trust your senses, but know that your senses can't sense everything that there is to be sensed.
What if we just hooked up a butterfly to a computer?
The butterfly would be like, whoa, lots of colors, man. But that's all I got. I just, wanted to talk about the Webb Telescope, and thanks for indulging me. I don't know if I presented it in such a cool way because I was trying to figure out the best way to organize it, but hopefully it's interesting.
Well, yeah, and when we'll have to do a follow-up episode when they actually have images to show, so we
I
can
know.
show those images off.
Oh, well, we have one image I could show you. Let's see. Webb Telescope image. There's only one that I've seen circulate. I'll send you a link.
Hmm.
Picture of a spider's web from a telescope.
A spider's web. I don't know. Let me try to find. I don't think that's the image. Let's see. There we go. Okay, all the images I'm finding are quite small, but those of you
Yeah.
listening, go find yourself Thomas Webb image. I'll send a link to Nick. And it is crisper. It is
Why is that
crisp.
not a link? It's just a wall of text.
Oh, well, Google Webb Telescope
Yeah, well,
image. It's
hold
the
on.
red one that pops
Yeah.
up.
I can see the image in that link. I've been too long in the Matrix. No, I'm just-
Mm.
I don't see the Matrix anymore. I just see blonde.
Oh, right.
Yummy steak.
Yeah, these are all super pixelated. This one's okay. Let's see. Yeah, a little bit more definition. There's a side by side here, so let me just try to open this up so I can show the audience. Okay.
Mhm.
Do you think we'll ever find anything outside of? Never mind. We already do.
So yeah, there's the images. You can see how much crisper they are. And I don't know, Nick, if you can zoom in on the right-hand side, I do think that the pattern formation, doesn't that look like a little snowflake?
But oh well, yeah, the stars. Yeah, they're
Yeah.
very pretty.
Mm-hmm.
Light beams are very nice.
Yeah.
Look,
And
when I saw stars like that, like if I ever saw light looking like that, I was always told to go see a doctor.
Yeah, it usually means you have astigmatism.
Yeah,
that's so funny.
what are we doing with these telescopes? We just
Giving
They
them
got
stigmatism.
they have a smudge on them. Now it's forever gonna look like that.
Did you
Nobody can
know?
wipe them off.
Did you know that happened to the Hubble though? They spent like $1 billion
believe it.
and the Hubble went out, and it was like a joke because it was like all this hype, and then the images were really fuzzy. And there was even like a Today Show where they were like making fun of how much money they spent on this shitty telescope. But so they had to send an astronaut up there to go fix it, and then it worked, and it's been awesome.
Mhm.
So, but that's the thing with this one is it's like it's going to be 1 million miles away from us. There's not really like an astronaut you can send to go fix it. So that's even why like it's even more incredible that we're going to wait for it to assemble itself, and that a team of people have put so much into making sure that it's done perfectly. Because if it's not, they just wasted like 9 billion or something like that.
who cares for those people?
I think it'll work. I mean, it's worked so far, and it's cool. It's got like a little sail on it.
If it doesn't work, figure out what went wrong and do it again.
Yeah, send a robot out there to go fix it. Done.
I think we should just have like lighthouse guards, but are like satellite guards. Like if that's your job, you're the astronaut that lives with the satellite for the rest of your life.
Oh my god, like that guy that opens the gate in Thor.
Yeah.
You're just the gatekeeper. Yeah,
Yeah.
makes sense.
Mm-hmm. But you're the one that guards and protects the satellite.
Well, imagine you start looking out there and you see worlds where they have, like DC characters, and you're like, oh snap, like consciousness really creates reality. There's all these new planets out there. Just kidding. I don't think that would happen.
You're like someone sends messages and like, don't you miss people on Earth? Don't you miss all of like movies and friends and stuff? And the person's just like, not really. It's kind of nice up here by myself.
Right.
So,
You get quite isolated. Oh, we got a comment here. Oh, love you too, Big Mike. It's good to have you listening in with us tonight. Thanks so much.
Anything.
Sorry, my microphone is messing the heck up. Hold on. I was trying to bring that onto the screen.
What,
Where
the
is it?
comment?
Yeah.
Oh, that's
There we go.
nice.
There we go. Hey, man.
Aw.
Love you too, buddy. Hope he's doing well.
Love you.
We got to get him on the show at some point. It'll be fun.
That'd be fun.
Talk to Ayla about horror movies.
Oh my God, I know. I've got I think I did the first 3 Friday the 13th movies. I've got like 7 more to go. And then I need to watch Firestarter, which is hilarious. If you haven't seen the trailer for that, there's a point where she's holding a lighter and she's just like, liar, liar, pants on fire. It's
So
like
cheesy.
it's so cheesy. So yeah, no, I need to do like a horror movie spinoff because that's my jam for sure.
Oh yeah.
But that's all I got. Space
Yeah.
horror maybe one day, but that's all
Space
I got.
horror. Oh yeah. Space horror.
So when we see
Space horror.
I know. Sorry, I didn't enunciate there. Space horror.
I said that. I was like, did I just say space
No,
horror
I did.
out?
No, that was me. Horror. There we go.
Horror.
Horror. Well, thanks, Ayla. I expect that we'll have a follow up to all of this too once we get some images in, so that we can talk about some of the potential findings. And yeah, it'll be interesting to follow up on this and see what we can see, and maybe we'll do a side by side with other telescopes and images and stuff, and we can compare and see if we can tell the difference. You know, not being scientists or anything. So, just if the layman can see with their naked eye a difference, that would be kind of interesting to figure out. But yeah, huh? What'd you say?
Ayla has homework.
Ayla's got homework. Yeah, she's gonna have to start tabulating all of the images, and we'll do side by sides, and then we can vote on which the best images are and whether NASA spent too much money or not.
Ooh, and what Avi Loeb thinks these days.
Oh God, what is
He's still talking about that rock.
He's still talking about it. But
Point the satellite towards the rock now.
yeah, exactly.
They don't know where it went, man. They can't.
It's strange. Yeah.
Maybe it went up.
Maybe we don't look that direction. So there you go. Thank you to Ayla for bringing the topic to the table. We appreciate you as always, and we hope that you guys listening in enjoyed as well. If you have any other comments, please feel free to leave them. My set's falling apart, guys. Sorry. I'm a mess today. So if you have any comments, feel free to leave them. Let us know what you think. What are you excited for about the James Webb Telescope? Drop that in the comments. We would love to hear from you. Thank you again to Big Mike, as always, for tuning in with us. We appreciate you, man. And yeah, if you want to check out podcasts that we do in our network of podcasts, this one is on Friday nights at 8 o'clock on Facebook and YouTube. We are also on Verbal, Rumble, and Odyssey. We have Screen Time Continuum, which is Mike, Keelan, Dijon, and I. That is Sunday nights and Wednesday nights at 8:30 p.m. You can go check us out on Facebook and on YouTube for that. Screen Time Continuum. Let's see. Dijon the Mustard has a Twitch channel called Strawberries and Coffee, and you can go check him out Tuesdays and Thursday nights at 10 p.m. Strawberries and Coffee. Go give him a thumbs up as well. Keelan's got 2 podcasts, one on Tuesday called If Numbers Could Talk, Tuesday nights at 8 p.m. You can go check him out Facebook, YouTube, and Spotify. He also has a podcast with his wife on Saturdays around 10 a.m. called This Married Moment, where you can check them out on Facebook, YouTube, and Spotify as well. But again, thank you to Ayla, and thank you to you guys for listening. We hope that you enjoyed. Stay out there, Cognonauts, and we will catch you on the next Exofathom. Good night.
Peace.
Live long and prosper.
That's a Star Trek.
It's on topic.
I did a Star Wars.